Okay, so welcome to yet another video for the Libre-SOC augmented 6600 design, which is based on the Cyber CDC 6600 from 1965. Much augmented to be precise exceptions, multi-issue, and a whole stack of other things with kind assistance from Mitch Alsop. So, I believe I covered this diagram in an earlier video, and if I can just zoom, yeah, wobble. Okay, so here you have the function unit to register dependency matrix, which feeds with some lines off to here into the function unit to function unit dependency matrix. And each of these cells will be latches. So in here you will have latches indicating which register is being used by the function unit for read or write purposes. But here is an absolutely critical additional matrix which latches which function unit depends on reading from another function unit and which one depends on writing. And that is a completely different proposition from which register is used to do reading and writing. So in the original 6600 design, you had, zoom out rather than in, there we go, you have in each of these cells here is an indication that the function unit is requires a read, which creates a which will latch this. If it's when it's issued, it indicates an intention to that reading is required, which tells anything on these rows that it using this here, this these OR gates here, tells it that under no circumstances must, for example, this function unit must any other function unit try and write, because this one is marked as an intention to read. So it's not which registers, it's just that reading is required. So when you get a go read signal, it cancels that latch. But you can see that it's latched on the clock because of the way that the 6600 original 6600 did latching some work on the on clock on the rising edge and some on the falling edge. We're not doing that in our design. We're just we're going with straight at positive edge issue. So the diagram is slightly different from this, but they're functionally the same. But I'm using these diagrams to describe the functionality rather than what it actually is. Anyway, now, so this at issue time, you get the indication that function unit needs to read latched into here for each individual cell, and to get latched in that it needs to write in individual cell, and consequently stops other function units from proceeding and overwriting the results, or not having them ready in time. However, what we've done is, if you recall from the prayer video I did yesterday, here's what I prepared earlier. We're going to go with multiple read signals and multiple write signals, and this here is the cell in here, not here, in this one. So consequently, this is the one that stores the register information. This is on a per register basis. All of that is in one of these individual cells here. But that we covered in another video. We need to cover in the things the modifications where now that we have more than one go read signal, more than one go write signal in this cell, we need to reflect that in the multiple go read and multiple go writes in the function FU-FU matrix as well. So where this is the original, now you can see that you have two of those latches. So there's one there, there's two of those, and this one corresponds to two of these. But otherwise, you have the same write wait signal and read wait signal because you only need the one. And the reason why I have two is because here's your function unit read signal, which goes to both gates, those things. Consequently, where in the original design, because there's only one read signal and one write signal per computational unit, here we have two latches that go on simultaneously. And when you get, and where normally go read would have said, okay, I am going to read from both ports, register file ports, and provide both operands simultaneously. That is the scheme that we are doing away with very deliberately, and as described sorry, it'll be the other way around, but here's the computational unit modifications that we did. Turn it around in your head. Turn it around in your head. Now, I think, all right. Here you can see you have the multiple go read signals coming in, and those are activated all simultaneously. All three must be, remember, all three must be activated. So here, likewise, we have back here, we have the same thing. You need an indication that for that cell that there's a particular that every single one of the reads has activated. So this will be for read port 1, this will be for read port 2, that'll be for write port 1, that'll be for write port 2, and rather than in the original 6600, you have the one signal, you got which indicates that both ports have been read, and the operands have been provided simultaneously to the computation unit. Now they're independent. So once both of these latches have gone high for read, they need to be they need independently to be cancelled. So this will cause this one to go off. But because there's a second one, you'll still have a second one waiting, so we still must not write. So consequently, with all the result together of both the two, or if there's three operands, you would have a third one of these, and there would be a third input to this OR gate here. And likewise for the writes, if you have two writes sitting in these latches here, right? You get these write requests which result in the go write signals, go write 1 and go write 2. When those have both occurred, only then will each of this operand have been pushed into the register file and that operand pushed into the register file, and only then is it safe to for following on dependence things in this rows rather than columns, in the rows, to say, okay, I can now it's now safe for me to read that result, which is because now that's been written into the register file. So we've gone from this. I could have just said, you go get one of them, and now you need two. And get one of them, and now you need two of them, two or three, and you store them together and blah. But I wanted to give a much more a little bit more comprehensive explanation of why that's the case, rather than just blah blah blah. Right.